Have you ever wondered how our world, the Earth, came into existence? This question has sparked curiosity in the minds of humans since time immemorial, driving us to explore the cosmos and to probe its deepest mysteries. Our universe is a vast expanse, filled with galaxies, stars and planets, all dancing to the cosmic ballet choreographed by the laws of physics. But how did this grand cosmic theater come into being? How did the stage and the actors assemble themselves into this magnificent spectacle that we observe today? For centuries, philosophers and scientists have grappled with these questions, leading to a myriad of theories and hypotheses. From the ancient cosmogonies that depicted the universe as an eternal and unchanging entity, to the modern theories of cosmology that propose a dynamic and evolving universe, our understanding of the cosmos has undergone a profound transformation. In the early 20th century, a revolutionary theory emerged that proposed a radical departure from the traditional view of an eternal universe. This theory, known as the Big Bang Theory, suggests that our universe began from a state of extreme density and temperature about 13.8 billion years ago. This singular event, a cataclysmic explosion, marked the birth of the universe. The Big Bang Theory, supported by a multitude of observational evidence, provides a comprehensive framework for understanding the origin and evolution of the universe. It describes how the universe expanded from an extremely hot and dense state to the vast cold cosmos we observe today. It explains the formation of galaxies, stars and planets, and the physical processes that shape the cosmic structures. In our quest to understand our place in the cosmos, we have developed sophisticated tools and technologies, enabling us to gaze deeper into the universe and further back in time. From telescopes to particle accelerators, we have harnessed the power of science and technology to unravel the mysteries of the cosmos. Our journey begins with a singular event, a cataclysmic explosion that marked the birth of the universe, the Big Bang. Imagine, if you will, the entire universe compacted into a space smaller than an atom, a place of unimaginable heat and density, where all the laws of physics as we know them cease to exist. This is the extraordinary premise of the Big Bang Theory, the very beginning of everything we know, everything we see, and everything that is beyond our sight in the cosmos. Around 13.8 billion years ago, this infinitesimal point of endless density and heat began to expand. This wasn't just an ordinary expansion, but an extraordinary and rapid inflation, an explosion of space itself. In a fraction of the first second, the universe expanded faster than the speed of light. It was a time of chaos and extreme conditions, a time when everything we know and understand about the universe was being forged in the crucible of creation. In these early moments, the universe was an incredibly hot, dense sea of energy. Matter as we know it didn't exist yet. Instead, there existed a thick, hot soup of fundamental particles. Particles like quarks and leptons, the most basic building blocks of matter. These particles were colliding with each other at high speeds, creating a storm of creation and destruction. As the universe expanded, it cooled down. This allowed the fundamental particles to stick together, forming protons and neutrons. Eventually, these particles combined to form atoms, the basic units of chemical elements. This process, known as nucleosynthesis, resulted in the formation of the first light elements. hydrogen, helium, and traces of lithium. These elements would later serve as the raw materials for the formation of stars and galaxies, setting the stage for the cosmic drama that would eventually lead to the creation of our own planet, Earth. The Big Bang Theory is more than just a theory about the birth of the universe. It's a story of creation, of the transformation of energy into matter, of the birth of time and space, and of the evolution of simplicity into complexity. From this violent beginning, the building blocks of the cosmos were formed. The universe, as we know it, had begun. In the expanding universe, particles started to come together, forming the first stars and galaxies. Imagine the universe as an enormous cosmic kitchen. The ingredients? Particles and atoms scattered across the universe like flour and sugar waiting to be mixed together. These particles, primarily hydrogen and helium, are the building blocks of everything we see in the universe today. In the heart of this cosmic kitchen, something extraordinary began to happen. The particles, drawn together by the irresistible force of gravity, started to clump together, forming clouds of gas and dust. These clouds are called nebulae, and they are the cosmic nurseries where stars are born. Within these nebulae, gravity pulls the gas and dust together into dense regions. As the particles collide and stick together, they form a spinning disk of material. In the center of this disk, a protostar begins to form. The pressure and temperature at the heart of the protostar become so intense that hydrogen atoms begin to fuse together, releasing a tremendous amount of energy. This energy lights up the protostar, and a new star is born. But what about galaxies? Well, the same gravitational forces that cause stars to form also lead to the creation of galaxies. As stars form, they can cluster together, drawn by the same gravitational attraction that initially brought the particles together. These clusters of stars form galaxies, enormous cosmic structures that can contain billions, even trillions of stars. In the vast cosmic kitchen, countless galaxies formed, each unique and beautiful in its own way. Among these galaxies, each with its own unique recipe of stars, planets and other celestial bodies, one stands out. This galaxy, a barred spiral galaxy with a bright central bulge and sprawling spiral arms, is our cosmic home. Among these galaxies, a particular one holds a special place in our story, the Milky Way. In a corner of the Milky Way, a cloud of gas and dust began to collapse under its own gravity. Picture this. Around 4.6 billion years ago, our neighborhood was nothing more than a sprawling cosmic cloud. Over time, this seemingly unremarkable cloud began to collapse inward, succumbing to the relentless pull of gravity. What caused this collapse? It could have been the shockwave of a nearby supernova or the gravitational tug of a passing star. Regardless, the collapse was inevitable. As the cloud contracted, it began to spin faster and faster, flattening into a spinning disk of gas and dust known as the protoplanetary disk. Now, imagine the heart of this disk, where the pull of gravity was the strongest. Here, matter started clumping together, growing denser and hotter, until finally a new star was born. Our Sun. The birth of our Sun was a profoundly energetic event, releasing vast amounts of heat and light and blowing away lighter elements from the inner regions of the disk. But what about the rest of the disk? The remaining gas and dust didn't just disappear, instead they started their own dance of creation. Tiny particles began to stick together, forming larger and larger clumps. Over countless millennia, these clumps grew into planetesimals, the building blocks of planets. In the inner solar system, close to the Sun, the heat was too intense for lighter elements to stick around. Here, planetesimals made of heavy elements like iron and rock came together to form the terrestrial planets, Mercury, Venus, Earth, and Mars. Further out, where the Sun's heat was less intense, planetesimals made of lighter elements like hydrogen, helium, and water. Ice could survive. These came together to form the gas giants, Jupiter, Saturn, Uranus, and Neptune. In this cosmic dance, a new player entered the scene, a planet we now call home, Earth. From a cloud of cosmic dust and gas, through a spinning disk of creation, to a system of planets orbiting a central star. The birth of our solar system is truly a story of cosmic proportions. From the remnants of the solar nebula, a rocky planet began to take shape. This is the story of our home, Earth, and its remarkable formation. Imagine, if you will, a swirling mass of dust and gas left over from the dawn of our solar system. This solar nebula, as it's called, was the nursery for the planets. Among them, a young Earth began to form through a process known as accretion. Accretion is the cosmic equivalent of a game of marbles on a grand scale. Tiny particles of dust and rock, drawn together by the irresistible force of gravity, collided and stuck together. As time passed, these clumps grew larger and larger, eventually forming planetesimals, the building blocks of planets. For our Earth, this process took a mind-boggling few tens of millions of years, but the story doesn't end there. As our young planet grew, so did the intensity of its collisions. These impacts generated immense heat, enough to cause the entire planet to melt. This molten state led to a crucial development in Earth's formation: differentiation. Differentiation is the process by which a planet separates into layers. In Earth's case, this resulted in the formation of the core, mantle, and crust. The densest materials like iron and nickel sank to the center to form the core. The less dense materials, such as silicates, rose to the top to form the mantle and crust. This process, like accretion, took millions of years. Through these violent and fiery beginnings, the Earth was shaped. From a spinning disk of dust and gas to a differentiated planet with a core, mantle, and crust. But it was far from the welcoming blue marble we know today. It was a molten, hostile world, bombarded by asteroids and comets. And thus our world was born, a sphere of rock floating in the emptiness of space. But stay tuned, because the story of our planet's evolution is far from over. Our newborn planet was a hostile place, but it was about to undergo incredible transformations. In its early days, Earth was a molten sphere, heated by the decay of radioactive elements and the residual heat from its violent creation. But over eons, our planet began to cool. As the surface hardened into a thin crust, the first landforms started to take shape. Volcanic eruptions were frequent and intense during this time, belching out gases that would form the first atmosphere. This early atmosphere was vastly different from what we breathe today. It was mostly made up of nitrogen, carbon dioxide, and water vapor, with little to no oxygen. As the Earth continued to cool, water vapor in the atmosphere began to condense, leading to the formation of oceans. These early bodies of water weren't the clear blue seas we're familiar with now. They were more like hot, mineral-rich soups. But it was in these primordial oceans that the next great transformation occurred. The emergence of life. The exact mechanism remains a mystery to this day, but somehow, amidst this chaotic brew of elements, the first simple organisms came to be. Over billions of years, these simple life forms evolved, diversifying and adapting to their environments. They developed photosynthesis, a process that uses sunlight to convert water and carbon dioxide into glucose for energy and oxygen as a byproduct. This marked the beginning of a gradual shift in the composition of the atmosphere towards one that could support complex life. The first multicellular organisms evolved around 1 billion years ago. From there, life on Earth exploded in complexity and diversity, leading to the vast array of species we see today. From a fiery ball of rock, Earth had transformed into a blue oasis of life. The story of Earth's evolution is a testament to the power of time and the fascinating, intricate processes that shape our universe. It's a tale of transformation, from a molten world to a thriving planet, teeming with life. So, our journey from the Big Bang to the birth of Earth is a tale of cosmic proportions. We began our odyssey with the mysteries of the universe, pondering the fundamental questions of existence itself. We delved into the enigma of the Big Bang, that initial singularity, that infinitesimal point of infinite density and temperature which erupted in a tremendous explosion about 14 billion years ago, giving birth to space, time, and matter. From there, we journeyed through the epoch of cosmic inflation, when the universe expanded at an astonishing rate, growing from a quantum speck to a macroscopic size in a blink of an eye. The energy of this expansion transformed into a hot, dense sea of particles, setting the stage for the formation of the first atoms. We then witnessed the birth of galaxies and stars, born from the gravitational pull of dark matter, forming cosmic webs of light and darkness. The stars, those cosmic furnaces, forget heavier elements in their cores, from helium to iron, through nuclear fusion, lighting up the universe and seeding it with the building blocks of future worlds. Our journey then took us to the birth of our solar system about 4.5 billion years ago. Born from a cloud of gas and dust, collapsing under its own gravity, forming a spinning disk with a central bulge, which ignited to become our sun. The remaining material in the disk coalesced into planets, asteroids and comets, including our own home, Earth. We then explored the formation of Earth, a violent and tumultuous time, marked by meteorite bombardments and volcanic eruptions. Over time, the Earth cooled, the crust solidified, oceans formed, and the stage was set for the emergence of life. The next chapter in our tale was the evolution of Earth, from a barren, lifeless world to a vibrant living planet. Life, once sparked, diversified and evolved, from simple single-celled organisms to complex multicellular life forms, culminating in the rise of humanity with our unique ability to ponder the mysteries of the universe. It's a breathtaking journey from the Big Bang to the birth of Earth, a cosmic tale of birth, death, and rebirth played out on a universal stage. It's a testament to the power of scientific inquiry, enabling us to peer back in time, to decipher the clues left by the universe, to unravel the secrets of our cosmic origins. It's a tale that puts our existence into perspective, reminding us of our humble beginnings, of our place in the cosmos, of our responsibilities as stewards of this precious planet. It's a tale that inspires awe and wonder, humility and reverence, encouraging us to cherish our home, to safeguard it for future generations, to continue our quest for knowledge and understanding. In the grand scheme of the universe, our Earth is but a tiny stage in a vast cosmic arena. Yet it's here that the greatest story of all unfolds, the story of life itself.